So, on homework 1.5, I'm going to do the first problem with you. Okay, the first problem gives you, number one, gives you that f of x equals 3 to the x power, right? And the instructions say find the indicated value of the function for each value of x. And it has this little thing up here that says x equals, and a brace around it that says -2, -1, 0, 1, 2, and 3, right? And you're supposed to find the indicated value of each value of the function for each value of x. What does that mean? Pop what in there? Yeah. So, a table. And right now, I'm going to show you guys how to do this. Right here, a lot of you guys have forgotten how to do the exponential functions from last year. You learned rules of exponents last year. Like, if I put -2 in there, 3 to the -2 power, that's equal to 1/9. How many of you know how to get that? From get 3 to the -2 power equal to 1/9. How do you do it? Yeah. So this is how you do it right here. Well, you guys, a negative exponent means you put it on the bottom and make it a positive exponent. Do you remember that from last year? You should have learned that last year. Okay? And what is 1 over 3 squared? 1/9. So -2 is 1/9. Okay? What's 3 to the -1 power? It's 1/3. It's 1 over 3 to the +1 power, right? What's 3 to the 0 power, you guys? It's 1. What's anything to the 0 power? Everybody write this down in your notes. Right now, everybody? Got it? Got your notes out? Any number to the 0 power equals 1. Any number to the 0 power equals 1. Any number to the 0 power equals 1. So 3 to the 0 power equals 1. Okay, 3 to the 1 power is 3. 3 to the 2nd power, 9. And 3 to the 3rd power is? 3 to the 3rd power means 3 times 3 times 3, which is 27. Yeah, I would like to see a little work on that, though. Okay, so that I understand you know what it means. Let me show you guys how to use your calculator. How many of you guys know how to put this in your calculator? Like 3. What does this caret key do, you guys? It gives it as an exponent. -2. Don't forget the negative. This key right here is the negative. What's this key right here? That's a minus, right? So make sure you hit that number. 3 to the -2 power. If I hit enter, I get a decimal. It's the same as 1/9, but this is how the calculator will actually change rational numbers. If it's a continuous repeating decimal, it will change it to a fraction. I have to do the math button, and number 1, fraction, and then hit enter again. And it changes it to 1/9 for you. Okay? How many of you knew that already?
I knew it, but I forgot it.
Okay. How many of you have remembered it, I should say? Okay. So that's what you do on problems 1, 2, 3, 4, and 5. I want you guys to go to problem number 4. Problem number 4 on your homework assignment. And you're given k of x equals 1/2 to the x power. And you're supposed to plug in all those numbers we just talked about. negative 2, negative 1, 0, 1, 2, and 3. And so I'm going to go 1/2 to the negative 2 power. What does this negative exponent mean again? Yeah, that's right. In this case, I can flip this fraction over. I can make it 2 over 1. And when I do that, I can make that negative 2 a positive 2, that power. So it's just 2 squared, which is 4. Because 1 squared is 1, and 4 into 1 is 4. So the answer right to this one is 4. Okay? If you want to put that one in your calculator, you would put it in like this, parenthesis, 1 divided by 2, ending parenthesis, caret key, negative 2, and hit enter, and you would see that you got 4. Now, here's the deal, you guys. I don't care if you use the calculator on some of these, but you need to think about the process here, because if you don't know your rules of exponents, when we start doing this with variables, you're going to be really confused, okay? If you don't know the rules of exponents, you don't know that 1/2 to the negative 2 power means 2 to the positive 2 power, then you're going to be in trouble later on. Or if you don't remember that 3 to the negative 2 power means 1 over 3 to the positive 2 power, you're going to be in trouble when we get working with the variables. So make sure you do that. But I don't mind you using the calculator. In fact, when you guys take the ACT test, if you really know how to use your calculator really well, and you know all those problems on the test, you can use your calculator to do like 80% of them pretty fast, okay? And the ACT test is about speed. They give you 60 minutes to do 60 questions. And some of them are difficult. They really want to, they really try to separate who knows this stuff and who doesn't know it. The highest score is a 36. I don't know how they weight it to make it like that. At our high school, we had a kid named Darren Ragazine. I think he got a 36 on the ACT, the overall, because there's 4 parts to it. There's a math, English, reading, and science. Those are the 4 parts. And I think he got a perfect score at 36 on it. He might have missed 1 or 2 questions. You can probably miss 1 or 2 questions and still get a 36. You can miss 2 on every one and still get a 36. How did you know all this? Oh, good. Okay, that's good. I don't even think most kids that took the ACT test know it. You got a 28? Excellent. Okay. Okay. The most we got, but you guys got to know this Darren Ragazine, you guys. This guy's got like 4 degrees from like Harvard, the MIT, which is the Massachusetts Institute of Technology. He was a super smart kid. He was just like brilliant. He took calculus in 9th grade. He took calculus in 9th grade. And what was that? He's totally what? No, he's not. He's an American just like you. He's a white American, actually. But, huh? But he, actually, this is what happened. He went on a mission to Ukraine, and he came back, and he came into the classroom to say hi to me. And I had this Ukrainian exchange student in there. It was the very first of the year. And he comes in, he was talking to me, and I told him, I said, hey, I've got this girl in here that's from the Ukraine. He goes, oh, can I come talk to her? And I said, yeah. So he comes in there, and he starts speaking in Ukrainian, and then she starts speaking back. She didn't know who he was, and he started asking her questions, and they were talking for a while, and we were all just sitting there listening. We didn't know what they were saying. And when they got all done, and he talked to me for a second longer, and he left. And he talked about math to all the students for a little bit, and then he left. She was like, who was that guy? And I says, oh, he's just a guy I used to teach. She goes, well, how does he know Ukrainian? Because I figured she must have asked him that, but she didn't. I said, he went on his mission and learned it. And she goes, is he from the Ukraine? And I said, no, why? And she said, he spoke the language perfectly, like he'd lived there all his life. I mean, this kid was super smart. He knew how to He knew how to do. He just knew all this stuff. So by the way, when he was in ninth grade, he took that calculus. He took like all these other calculus classes and math classes. By the time he graduated, he took all these online classes. He still went to school here and took some of these fun classes that he liked to do. But he took all these online classes. By the time he graduated, he already had his degree, an online degree from one of those colleges. I can't remember which one. He came back from his mission and went out, and in 2 years he finished he finished a couple of degrees at a couple different colleges. That's how smart he was. Now he makes a lot of money, I think. I heard he lives in La Verkin and he works online. So that's what I heard, but I haven't seen him for a while. But he was extra smart. He knew a lot more math than me. So. Why not? What's wrong with La Verkin? Okay. Come on, let's be proud of La Verkin. All right. I lived in La Verkin 1 year of my life. I'll never go back. No, I'm just kidding. Okay. Okay, problem 19. This one's pretty easy. All it wants me to do is to evaluate these functions. I'm going to do number 19 with you. Number 19 is we're given f of x equals x squared plus 10. And it wants me to find f of 9. How many of you guys know this notation? Know what it means to do? Raise your hand if you know what it means to do. One guy? Okay, most of you then. Okay, what do I do? Good. Put a 9 in for x. 9 squared plus 10. What's 9 squared? 81. Plus 10 makes 91. So my answer is 91, right? Okay, now, is this the same stuff we were doing on the first page? Oh, yeah. It is. It's plugging in numbers into a function, right? Now, are they different kinds of functions? What are these functions back here so far? Most of them, down to 23, are what kind of equations? Listen, you guys. From 19 to 23, what kind of equations are they? They're quadratic. What kind are 24 and 25? Those are exponential. Look back on the first page. What were all 5 of the first 5 problems? Don't guess. Look. They're exponential. What makes an exponential function? It's power of x. If it's power to the x, it's exponential. If it's x to the second power, it's quadratic. Do you guys see that? What makes a function linear? Huh? Things that act. But what does an equation look like? Okay, y equals 2x plus 1 is an example, right? Y equals 3/4 x minus 7 is 1, right? Anything where x is to the first power, right? That's going to be a linear equation, right? Okay. All right. I want to do number 23 with you. Let's go to 23. 23 wants us to find s of 1/2. And it's equal, and s of x equals x squared plus 5/4 x minus 1/2, right? So if I plug 1/2 in there, I get 1/2 squared plus 5/4 times 1/2 minus 1/2. You should know the order of operation to get this, right? What's 1/2 squared? In your head, you guys. It's 1/4. Because I square 1. 1 squared is 1. 2 squared is 4. So I get 1/4. What's 5 fourths times 1/2? It is 5/8 because you go 5 times 1 and 4 times 2. 5/8 minus 1/2. 1/4 plus 5/8 minus 1/2. If I had to get a common, I got to get a common denominator. What's my common denominator going to be, you guys? 8, right? 8 is going to be my common denominator all the way across. I times 4 by what to get 8? So I got to go 2 times 1 is 2. Yeah, this one didn't change. The middle one didn't change. And 1/2 goes to 4/8. What's 2 plus 5? 7. Minus 4 is 3. So my answer is 3/8. All I have to do is add and subtract the top numbers, right? So I get 3/8. Now, could have I done that one on the calculator? I could go like this. 1/2, so parenthesis, 1 divided by 2 squared. Oh, I did. Parenthesis, 1 divided by 2 squared plus 5 fourths, parenthesis, 5 divided by 4. Oh, my plus sign didn't. Sometimes my So 1/2 squared plus 5 fourths times 1/2 minus 1/2. 0.375, which I can change to a fraction by going math, 1, and enter. And I can get 3/8. Which way is easier on that one? By hand or by calculator? Here's the other thing, you guys. I don't mind if you do it on the calculator, but if you don't know how to manipulate fractions by getting like common denominators and adding, subtracting, you're going to struggle in some parts of this class, okay? So you got to learn how to do that by hand. Okay. Now, you guys, problems 6 through 18 all pertain to this Empire State, or the Sears Tower in Chicago. But to do that one, before we do that one, I want to go back to that task we were working on the other day. Will you guys get out those papers for that task we were doing the other day? Okay. You guys, the other day when we were doing this, I think we were getting a little confused, okay? I want to make sure we understand this. So all eyes right here for a second. Okay? All eyes right here. We're going to talk about this. Remember, if we drop a rock here, how far is it after 1 second? Okay, after 1 second, it has gone 32 feet, right? Because that's what gravity pulls things to Earth. Okay, after 2 seconds, after the second second, how far does it travel during the second second? 64 feet. And I'm not asking for the total yet, right? But we're going to talk about that later. The third time is going to be 96. It's not double 64, it's 96. You add 32 each time, right? It gets going 32 feet faster each time, which is going to be what? So the 4th second, it's actually going to travel 128 feet that 4th second, right? Okay, and so forth. The 5th second is going to be 160, and so forth. Anytime it keeps going up, the rate at which it's increasing is increasing by the same amount, which is 32 right here. We call that a constant rate of acceleration, okay? And if you remember when we did this problem right here, it asks us to consider that a car that is traveling at a steady rate of 30 feet per second at time t equals 0, the driver of the car starts to increase his speed, or in other words, he starts to accelerate in order to pass a slow-moving vehicle. The speed increases at a constant rate So that 20 seconds later, the car is traveling at a rate of 40 feet per second. So we did this right here. I'm going to go, this is time down here. This is 0. I'm going to say this is 10 and this is 20. So that's 20 and that's 10. Or you know what? Maybe we go in 2s so we just can see this a little bit better. Let's go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, that's our 20-second interval. Okay, here's 5, 10, 15, 20, 25, 30, 35, and 40 right here. Okay, so at time equals 0, how fast is he traveling it when time equals 0? 30. So we put a mark here. At time equals 20, how fast was he traveling? 40, which is right here, right? And if we drew a straight line between those 2 points, that wasn't a very straight line. But if we drew a straight line right here, okay, it asks us to graph the car speed as a function of time for this 20-second interval, right? And then it also asks us, what is the average speed? Oh, no, I went way too far, huh? Calculate the average speed of the car for this 20-second time interval. What was the average speed of that car for that 20-second interval? How did we figure that out? We went we went 40 plus 30 divided by 2. We took the starting time and the ending time, we added them together, we averaged them. And what did we get? So the average speed of this car was 35 feet per second, right? And then find the total distance the car travels during this 20-second interval time. How do we figure that out? How do we figure that out, you guys? How far did it travel during that 20-second interval of time? Right there? Okay. During that 20-second interval of time, we use this formula. Distance equals rate times time. Do you remember that? And we wanted to know how far. Well, to find the distance, we got to take the rate, which was the average rate, which was 35. We times it by the time, which was 20 seconds. And what did we get? 700 feet. What was the other way we found out we could do this problem by, you guys? Actually, I think I need to go down a little bit, right? Right there. Okay. Do you remember we found out we could find the area under the curve? If I found that area right there, that area was 700, right? Because we could break it down into a rectangle and a triangle. The rectangle was 30 by 20. So 30 times 20 was 600. The triangle was 10 by 20 divided by 2, right? 20 times 10 divided by 2, which was 100. We add those together, we got 700 feet. Do you guys remember doing that last time?
Talk about how calculus figures out if it's a wavy line. Would it be easier just to plug it in calculus formula?
Well, not in this one because, well, actually this one, you probably could, yeah.
Would it take long?
No, I just have to remember how to do it. I'm thinking about it to see if I can remember. So we would have, we're doing this as, we're looking for the distance. And we're doing it according to time. So it would be, the rate would be 35. So D equals 35T. And then we'd have to, I can't remember how to restrict it on there. I'd have to go back and learn about derivatives. It's been 22 years since I've done calculus. More like 25. So I'd have to go back and remember. But I have never taught calculus in high school. Well, I had the opportunity to do it one time, but I turned it down because if I was going to teach calculus, it would take me the whole summer to get rid of it, ready for it, and I didn't have time that summer to do it. I had too much going on. So I wish I would like to teach calculus again, but I just would need the time to prepare for it. Calculus is a fun subject. It's where you apply everything. Okay, now going up right here, you guys. Explain how to find the area. Okay, we did all that. Let's go up to this problem right here now. I'm going to clear the ink off of here. Okay, we did the same thing with the penny. Do you remember we did this with the penny? What will be the speed after 1 second of the penny that's dropped from the Empire State Building? What will be the speed after 1 second, you guys? 32 feet per second, because we know that acceleration due to gravity is 32 feet per second. Graph the penny as a function of time in 1 second interval. We did that. What is the average speed of the penny in the 1 second? The average speed wasn't 32. What was the average speed, you guys? 16, because remember we took the starting point speed, which is 0, the ending speed, which is 32. We add them together, divided by 2, which is 16. We found the average of the starting and the ending speed, in other words, right? What is the total distance that the penny fell in 1 second? And it fell 32 feet. What's another way we could come up with that? Using the average speed. What's another way we could use the average speed to get it? How long did it travel? It traveled for, let's see, what is the total distance that the penny fell in the 1 second interval? Well, if we graphed it in the 1 second, I can't remember if it's, I think it's talking about between 0 and 1.
Yeah.
Well, we said that last time, didn't we? But this is what I'm thinking. Its speed after 1 second was 32 feet per second, wasn't it? So after 1 second, it was going 32 feet per second, but it wasn't going that same speed the whole time, was it? Well, wait, no, it fell 32 feet in that second. Yeah, it's 32. Okay? It's 32. Okay, now, this is what I wanted to do, and I can't remember how far we got on this last time. How far did we get on this one right here? We didn't get any further than that?
We started doing the graph.
Okay, basically, there should have been, you guys should have had a couple of columns. What were those columns? Create a table for the speed of an object that has dropped from a height of 200 feet above the surface of the moon as a function of the elapsed time. Okay, speed as a function of time. So we have time, we have speed, which is also known as rate, right? Okay, add another column right here. Down here at number 2, it says add another column to your table to keep track of the distance the object has fallen as a function of time. So we're going to go distance. So time, okay? We're going to go 0, 1, 2, 3, 4, 5, 6, 7, 8. I told you guys to go down, all the way down to 8, didn't I? And if you guys go all the way to 8, okay, what was the speed? What's the speed after 0 seconds? 0 after 1 second? 32 after 2 seconds? 64 after 3 seconds? After 4 seconds? After 5 seconds? 160 after 6 seconds? And after 7 seconds? Oh, wait, this is on the moon. That's a good question. I'm going to explain that right now. Everybody listen. Why would we need to do that? This is why. Because some people do go to the moon. But yeah. You guys, every problem you're going to have to solve in life is not going to come up. You're not going to learn it before you do it, right? So you have to learn how to think. And the whole idea of teaching math in school is to teach you how to think about things. And that's what we're doing. We're learning to problem solve. So that's why we do it, okay? So that's why we do it. Okay, what is the acceleration due to gravity on the moon, you guys? 6 seconds. So at 6, then what? 12. Oh, whoops. I put 0 up there first. 0. After 1 second, 6. Then after 2 seconds, it's going 12. Then 18 feet per second. 24 feet per second. 36. 42, and then 48. Okay, did you guys fill out this table too? Okay, so 0, 6, then what? 18, because it was the 6 plus 12, right? 18 plus 18, 36. 36 plus 24 is 60. 60 plus 30 is 90. 90 plus 36 is 126. 126 plus 42 is, huh? 168. And 216, right? We had it filled out to there. Is that how further we got? And we're almost out of class today, but we got time. We're going to see if we can figure this out. Okay. Now, okay. Approximately how long will it take the object to hit the surface of the moon? Well, can we use this table to approximate that, you guys?
Yes.
What is it approximately? About between 7 and 8 seconds. We could be more precise by dividing, 168 by 216, right? And getting the decimal and just adding that to 7. But it's about 7 point what? Did someone say? 7 and, I think it's 7 2/3 is what we got in my other class when we did it. Okay, 7 2/3. Okay, write an equation for the distance the object has fallen as a function of elapsed time. So, how many of you guys wrote an equation for this one right here? For this column with the elapsed time. How many of you guys did that? What did you guys come up with? Yeah, what did I do? Oh, we already did this part too? Oh, okay. Oh, I did it with you guys. That's right. What did we get? Okay, 3. I'm going to use time. 3t squared plus 3t. Is that what we came up with? 3t squared plus 3t. This is t of d. Actually, I should have put a d there, not a t. What was I thinking? 3d squared plus 3d, right? Okay. Hey, by the way, you guys, the way I came up with this function is the way we did that one the first of class. We doubled it. I would just start with 6 right here. Double 6, you get 12, 36, 72. Oh, wait, maybe I didn't double it. That's 2 times 3. That's 3 times 6. Oh, I didn't have to double this one. Did I double it when I did it with you guys the other day? 2 times 3 is 6. 3 times 6 is 18. 4 times 9 is 36. 5 times 12 is 60. You guys see this pattern? 6 times 15 is 90. I had 2 linear factors right here. Do you guys see that? Okay, and this was step 1. Step 1, I had a 2. So the difference between these terms is all 2. The difference between those terms is 3. So I did. So this one was 2x or 2d. And I mean, yeah, 2d or 1d, because the difference is 1. So 1d, if I put 1 in there, 1 times 1 is 1 plus 1 is 2, right? 2 times 1 is 2 plus 1 is 3 and so forth. So the first factor was d plus 1. The second factor is just d. I mean 3d. The difference between terms is 3, so is 3d. And if you distribute those, you get that up there. Do you see that? Is anybody listening out there?
I was.
All right. Okay. Yeah, the rain is entrancing. Okay. Anyway, we wrote an equation. We're going to leave it at that. Your assignment, you guys listen. The Empire or the Sears Tower building is that's on your assignment. That's your assignment to finish every problem on that worksheet I gave you, including the Sears Tower problem, all from 6 down to 18 or whatever it is. Okay?